Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night.
I'm your host, Wayne Zuhl, and this is the Astro Guy podcast. This is a jam-packed episode. There is a lunar occultation of Mars. The moon is near several planets at various times this month. Mars reaches opposition. Venus and Mercury return to the evening skies, and there's a meteor shower. Not to mention that Artemis 1 finally lifted off and will be back on Earth around December 5th. We will also explore the constellations Cassiopeia, the Queen, and Triangulum, along with some of the wonders that they each hold. But the biggest event of the month occurs on December 7th and 8th, when Mars will be occulted, or covered, by the moon for most of the United States. Most of the eastern seaboard, except for parts of northern Maine, will experience a near miss, as Mars will come close but not be covered by the moon. Folks along a path that's several miles wide will experience a grazing occultation, where parts of Mars will be visible while other parts will appear behind the moon. The closest approach for New York City will occur a little after 11 p.m. on the 7th, where Mars will miss the moon by less than 2 minutes of arc. For reference, the width of your pinky at arm's length is 1 degree, or 60 minutes. Mars will be 17 arc seconds wide at the time, so there will be plenty of space between the two from New York City. But if you were in New York and you were to drive an hour to the north or the west, you could be right on the graze line, while a short distance further would allow you to see all of Mars disappearing behind the moon. In the previous episode of this podcast, I conducted an interview with Joe Rayo, and he gives a great presentation about the occultation. So for all the details on it, I suggest checking out that episode. Observing the occultation through a telescope is your best bet, as Mars nears, grazes, or goes behind the moon, depending on your location. Either way, it should be a fun event to see. If it's cloudy where you are on occultation night, there will be several live feeds available. Just search Mars Occultation 2022 live feed. Mercury emerges from the glare of the sun around the 10th of December into the evening skies. Mercury glows at magnitude 0.5, but it's low, and it's only just a few degrees above the horizon during twilight. You'll likely need binoculars to pick it out. About a half hour after sunset, Mercury is less than 4 degrees above the southwestern horizon, but the planet will climb higher in the sky each night until the 21st, when it's at its greatest eastern elongation, just over 20 degrees away from the sun. Even when Mercury is at its highest during twilight, it's still less than 10 degrees above the horizon. You'll need a very good southwestern horizon to catch Mercury this time around. A bit easier to spot is Venus, which careful observers should be able to spot low in the southwest starting around December 21st. Venus is much brighter than Mercury, so you should be able to spot it without any optical aid, although binoculars will help during twilight. Venus shines brightly at magnitude minus 3.9. On December 24th, the 1.7-day-old moon will join Mercury and Venus low in the southwest. The trio will form a beautiful isosceles triangle. To spot them, you'll need an excellent horizon, and binoculars will definitely help. Good luck trying to spot it. Mars is the show stealer this month as it reaches opposition on December 8th. At opposition, the Sun is opposite Mars in the sky, so Mars will rise when the sun sets and set when the sun rises. It is also when Mars is closest to us. This opposition isn't as favorable as the 2020 opposition was, but it will be the best Mars opposition for several years. It won't be until the 2030s, when the Earth's orbit and the orbit of Mars match up for the planet to appear near its best. At this opposition, Mars spans just over 17 arcseconds across. For comparison, during the 2018 opposition, Mars spanned just over 24 seconds of arc. So while this is the best that Mars can be for some time, it's not the best that it can be. Mars spends the entire month in the constellation Taurus and is easy to spot due to its ruddy orange color, and it will be shining bright at magnitude minus 1.9. You'll need a telescope to spot any details on the surface of the planet, but the polar caps, as well as bright and dark markings on the surface, begin to show up at around a magnification of 100. Of course, the quality of your optics and atmospheric seeing play a huge role in how good Mars will look. Mars does have occasional planet-wide dust storms that can obscure surface details, so be aware of that when observing the red planet if you don't see anything. As I mentioned earlier, on the evening of the 7th going into the 8th, Mars will either come very near the Moon or be covered by it depending on where you are. Again, please check out the previous episode with Joe Rayo, where he gives a great presentation on the occultation. Jupiter is very bright and well placed in the evening sky as December begins. Jupiter spends the entire month near the circlet of Pisces. As the month begins, Jupiter is high in the southeast and shining brightly at magnitude minus 2.57. It will dim slightly as the month goes on, ending December at magnitude minus 2.35. As the month begins, Jupiter spans 43 seconds of arc across, while at the end of the month, it will appear to have shrunk to about 39 seconds of arc. Binoculars should reveal the 4 Galilean moons, and if the seeing is good, you might spot a band or two on Jupiter itself. In a telescope, you can see lots of details, bands, festoons, and when it's facing us, the great red spot. Jupiter appears to be constantly changing. I suggest always give it a look when it's in the sky. The Moon gets in on the action with Jupiter twice this month. On the 1st, the 9-day-old Moon will be 2.5 degrees away from Jupiter. Their closest approach occurs around 11 p.m. Eastern Time. Then, on the 29th, the Moon will come within 5.5 degrees of Jupiter. These near passes will be stunning to see with binoculars, or just your naked eye. Saturn starts the month in the southwestern evening sky, and by month's end it will be tough to pick out of the twilight glow. So get your Saturn views in now, as in January it will be lost in the glow of the sun and won't reappear in the morning skies until around the 3rd week in March of 2023. Saturn dims slightly as it starts December at magnitude 0.79, and by the end of the month it will be down to magnitude 0.86. Still bright, but tough to spot during twilight. Of course, Saturn's standout feature is its ring system. You can see them in binoculars, but to really appreciate them, you'll want to observe them with a telescope. Saturn spends the entire month in the constellation Capricorn. On the 26th, as the sky is getting dark, look for Saturn and the 4-day-old crescent moon in the south-southwest. The pair will be separated by about 4.5 degrees. Uranus spends the entire month in Aries and is faint, but visible to the unaided eye from a very dark location. The planet glows at magnitude 5.7 and appears small, spanning only a little more than 3.5 seconds of arc. You can easily spot it in binoculars, and in a telescope, it will resemble a bloated greenish-blue star. It's very difficult to spot any details on the planet, but you might be able to spot some of its brighter moons, which are faint, with the brightest, Umbriel, being magnitude 15, so it's definitely a challenge to spot the moons. Neptune starts the month about 6 degrees west of Jupiter. By month's end, it will be about 8 degrees west of Jupiter. Neptune is visible in binoculars, and you'll need a telescope to make out its blue disk. It only spans about 2.5 arc seconds, so you'll need to bump up the magnification to make out the disk. Neptune is faint at magnitude 7.8. You can try to challenge yourself by spotting Neptune's brightest moon, Triton. Triton glows dimly at magnitude 13.5, so you'll likely need an 8-inch or larger scope from dark skies to try to spot it. The evenings of the 13th and 14th will be the best times to view the annual Geminid meteor shower. On the 13th, the moon rises around 9:30 p.m., so your efforts will be impeded by the moon, but it's still worth trying to see them. The best views should be between midnight and 5 a.m. The morning of the 14th will have a little less moonlight to deal with. The shower is predicted to have a zenithal hourly rate of 150 meteors, but that's under perfect moonless conditions. And while the Perseid shower in August is known for its bright meteors, but the Geminids tend not to be as bright, which is why dark skies and no moon favors this shower. Geminid meteors do move very swiftly compared to other meteors. It's worth braving the cold to try to spot some if it's clear. The sun will reach its furthest point south for the year on the 21st. This is the winter solstice, and it occurs at 4:47 p.m. on the 21st. This is also the start of astronomical winter. This day also has the shortest amount of daylight for the year. Each day going forward until the summer solstice in June will see the days getting longer and longer. See, I told you that this was a busy month for our solar system. So, moving outwards, let's take a look at 2 constellations that are best viewed in the evenings during December. As darkness falls in December, Cassiopeia is high in the north. Easy to identify as 4 second and 1/3 magnitude stars, forming a stretched capital M. The constellation is supposed to represent Queen Cassiopeia, sitting on her throne, but to me, it appears like an elongated M, or a W, when it's low in the sky during the warmer months of the year. From 40 degrees north latitude, the constellation is about 65 degrees above the northern horizon, making it easy to spot. The brightest star in Cassiopeia is the magnitude 2.23 star Centaur, or Alpha Cassiopeiae. This yellow-white star is the top left star in the M. It is also a double star, having a magnitude 8.93 secondary star that is just over 1 arc-minute away. A 3-inch or larger telescope should be able to resolve the 2 stars rather easily. Centaur is located about 230 light-years away from us. Calf is the second brightest star in Cassiopeia. Slightly fainter than Centaur, at magnitude 2.27, it represents the bottom left star of the M. Also a double star, Calf's companion is much fainter, more than 11 magnitudes fainter, in fact. They are separated by about 30 arc seconds, so you'll need an 8-inch scope at a minimum to try to spot the companion star. Calf is located about 54 light-years away from us. Cassiopeia holds a wealth of deep sky objects that are within easy reach of binoculars or small telescopes. The brightest deep sky object in Cassiopeia is the open cluster NGC 457, also known as Caldwell 13, the Owl Cluster, or the ET Cluster. To me, it actually looks like ET, with two fifth magnitude foreground stars representing the eyes, and the rest of the cluster making up the arms, body, and those short legs of the fictional extraterrestrial. Glowing at magnitude 6.4 and spanning about 13 minutes of arc, this cluster is easy to spot in binoculars. The eyes are easily resolved, with the rest of the cluster appearing as a mottled patch of light. In a telescope, you'll be able to resolve dozens of stars within the cluster, and the ET or the owl shape should be obvious. NGC 457 is made up of about 60 stars and is located about 7,900 light-years away from us. To locate NGC 457, start at Rukba, the top bright star in the M, and go 2 degrees south and 1 degree west, and you should easily spot the cluster. If you're watching this on YouTube, you'll notice that there are 3 red circles around the object. This represents the view in a Telrad reflex sight. The inner circle is half a degree, the middle circle is 2 degrees, and the outer circle is 4 degrees wide. If you have a Telrad or a red dot finder, the markings on these charts will be a big help for you. Another bright and easy to spot open cluster in Cassiopeia is M52, which is near a bonus object that we'll also explore. This cluster was discovered by Charles Messier on September 7th, 1774. This cluster is rather condensed as far as open clusters go. It is sometimes referred to as the Scorpion cluster. It is located about 1,400 light-years away from us, and its member stars are pretty young, at around 160 million years old. The cluster is large, at about 13 minutes of arc, and glows at magnitude 6.9. If you're not sure what minutes of arc or magnitude mean, I'd urge you to listen or watch episode 1 of this podcast, where those terms are explained. Once you grasp the terms, they're easy to understand. You can spot M52 in binoculars, where it will appear as a fuzzy glow about half the size of the moon. In a telescope, you'll be able to resolve a couple of dozen stars, with 2 eighth magnitude stars being the brightest in the cluster. So this cluster has a bonus object that is only a half a degree southwest of it. I'm referring to the famous emission nebula NGC 7635, also known as Caldwell 11, but known famously as the Bubble Nebula. The shape of the gas is created by the stellar wind from the 8.7 magnitude star SAO 20575. The outer regions of this nebula are easier to spot than the bubble itself. It's best to try to spot this on a dark, moonless night with a 6-inch or larger telescope. Waiting for this to climb high in the sky will be a help, as will a nebula filter, such as an O3 filter, which will be a huge help in spotting the nebula. To locate M52 in the bubble, start at Shadar and sweep towards Kaf. Continue sweeping in that line 6 degrees past Kaf, and you should be able to spot M52. This area of sky has lots of great open clusters to explore, and M103 is one that you'll revisit time after time. Slightly smaller and fainter than M52, M103 spans 6 minutes of arc and glows at magnitude 7.4. In binoculars, you'll see it as a small smudge with a couple of stars resolved, while in a telescope, you'll be able to resolve many of the cluster's 40 member stars, which are mostly between 10th and 11th magnitude. There's a reddish star nearly in the middle of the cluster. Can you spot it? M103 is about 10,000 light-years away from us. To locate M103, start at Rukba and sweep 1 degree east and half a degree north, and you'll see the cluster. The last object that we'll explore in Cassiopeia is NGC 281, commonly known as the Pac-Man Nebula. This emission nebula surrounding the open cluster IC 1590 is large, spanning about 20 by 30 arc minutes. The nebula is faint, so you're going to need a 6-inch or larger scope at low power to try to spot it. The cluster within the nebula is magnitude 7.2, but it's made up of 279 faint stars. In a telescope, it will look like a small mottled glow. While this can be a challenge, I have observed it with a 70mm refractor under very dark skies. Again, a nebula filter will be very helpful in spotting the nebula itself. Surprisingly, the nebula shows up relatively easily in short exposures. I have been able to capture it with a DSLR and a 200mm lens in only 10 seconds of exposure time. To locate the Pac-Man Nebula, start at Shadar, the top left star on the M, and sweep just over 1.5 degrees east, and you should have it in your field of view. Now, we'll head a bit farther south to the small constellation Triangulum. Around 8 p.m. on December evenings, you'll be able to spot Triangulum nearly overhead. The constellation is marked by 2 third-magnitude stars and 1 fourth-magnitude star that form a right triangle, giving the constellation its name. Triangulum is one of the smallest constellations in the sky, spanning only 132 square degrees. The brightest star in Triangulum is third magnitude Beta Trianguli, which is a white giant star. It lies 124 light-years away from us. Surprisingly, Metalla, or Alpha Trianguli, is 0.4 magnitudes fainter than Beta. In most constellations, the star with the alpha designation is usually the brightest star in the constellation. Triangulum breaks that norm. The most famous object within Triangulum, and our last for this episode, is the famous Triangulum galaxy, known as M33. This galaxy is the third largest in the local group of galaxies, behind the Andromeda Galaxy and our home, the Milky Way Galaxy. It is also one of the furthest things that is observable with the naked eye, at 2.73 million light-years away from us. However, you need to be under pristine conditions to spot it without any optical aid. I have done it several times, but it is difficult to pick out of the background. Binoculars from a dark location will show the galaxy as a faint glow, and in a telescope at low power you might be able to make out the spiral structure and some of the brighter H2 regions, the brightest of which are around magnitude 13, so they are a challenge. M33 spans about 60 by 40 arc minutes, so it's more than 2 times the size of the full moon. Even though its magnitude is listed at 5.7, its light is spread out over a large area, giving it low surface brightness. To locate M33, start at Metalla and sweep 4 degrees west and 1 degree north, and you should see the galaxy. Low magnification will help you spot this sometimes elusive galaxy. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night.
I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe noctem. Seize the night.